All right, we're on video 5 for lesson 2, section 1.3. I think we're about on mile 18 of the marathon, so only 8 more to go. Number 6 here, we were talking about how you get it into sort of like the standard form for sine and cosine, which kind of reveals, here's the amplitude value. If you factor this out of the x term, it gives you an avenue for finding the period. This number is going to be the horizontal shift. Minus means right, plus means down. The vertical shift is whatever's added to or subtracted from on the outside. A plus k means it shifts up. A minus k means it shifts down. With all that in mind, these are pretty simple. All you got to do is know how to factor and observe. So we got another tricky situation where there's a negative that's occupying this b value right here. So I'm going to put brackets. We are dividing out the negative 2/3 from both parts, right? That's what factoring is, leaving us with x, and then negative pi divided by negative 2/3. If you can visualize, just think, I'm taking pi, and I'm multiplying by the reciprocal of the thing it's dividing by. So you can just say it's pi, not divided by 2/3, but times 3/2. Pi times 3/2, 3 pi over 2. And since it's a negative over a negative, it's a plus. And now we have to make a decision about that whole idea of there's a negative plugged in inside. Is sine an even function or is it an odd function in terms of does the negative come out or does the negative leave the function unchanged? Sine ends up being an odd function where the negative certainly does have an effect on the outside of the function. I went into great depth on this with in pre-calculus, so I'm kind of banking on the fact that you guys remember me talking about this, so I'm not proving it for you. Unless we want to do an ultra marathon. Nah, let's just keep it. Let's keep it to one final video. All right, so we've got it in the form that allows us to kind of think things through. Our amplitude is going to be, again, the absolute value of negative 1. The period is going to be 2 pi divided by b. Our 2 pi divided by b is, well, 2 pi over 2/3. Again, think of it's 2 pi times 3/2. 2 pi divided by 2/3 is times 3/2. The 2's cancel, so you're left with 3 pi over 1, which is just 3 pi. So that actually, if it's a number that's less than 1 like this, it increases the distance of the period. It kind of like widens out the distance it takes from sine to kind of recycle itself. The horizontal shift is equal to left 3 pi over 2. And there's nothing added to or subtracted from. That would be no vertical shift. No vertical shift. I know, I'm using shorthand now. Oh my goodness. Here. And there is a vertical reflection. Maybe we could just say yes to vertical reflections. All right, since we're here, why don't we talk about number 4 as well? Because tangent, it has some different components to it, so I don't want to leave you guys out in the cold with your tangent functions. So number 4, I'm going to rearrange it like I've done with some of the other ones. Inside, I'm going to rearrange as well. Plus 1. All right, these examples are pretty good because they all make you have to figure out, okay, what's the deal with the negative in front of the x value? So I'm dividing out the negative 2. So you get negative 2 times x, plus divided by minus is a minus. Pi over 2 divided by 2 is, just think of it as pi over 2 is getting cut in half. So it's like a half. What's half of a half? it's a fourth. So taking a fraction divided by a whole number just means multiply the denominator by that. So pi over 4. If you don't get my shortcut explanations on those, just go off to the side and literally rewrite it horizontally, pi over 2 divided by negative 2. Put it over 1, flip the second and multiply. I'm okay with, we got to figure it out, so revert to whatever standard you have to. That negative now, we have to make a decision about whether or not tangent is even, and it just sort of like says that negative inside will not change the outside, or if it's odd and it does actually change it and should come out. All these markers are running out of steam. Tangent ends up being odd. Now, we generally don't describe an amplitude for tangent, so I'm just not going to write amplitude. Its period, though, is different. If you recall yesterday when we had asymptotes at negative pi over 2, you drew your tangent function, and then the asymptote reappeared at pi over 2, it only took pi units. Pi over 2 plus pi over 2 is pi units in order to recycle our tangent function. So the period for a normal tangent is not 2 pi, it's actually pi. So we would take pi divided by that b value to determine what our period would be. So this tangent function actually gets skinnier, which means it makes total sense that the period is now pi over 2 instead of pi. What else do we got to decide? Yeah, horizontal shifting works just like cosine and sine. This means right pi over 4 units. This means the vertical shift is up 1 unit, and the negative means it is a reflection. Reflects? Yes. All right. Now, what if I asked you to build some of these functions from I guess, preordained characteristics? And that's what 16 through 19 is all about. If we have time, I'll get back to 13. 13 is kind of what we're doing here, but just lots of variables getting thrown in. So let's say 16. You've got I want to put both of these in the picture. Let's hope this works out, guys. Maybe. We'll try. Yes. Okay. Number 16. A sine function that's reflected vertically, shifted up 3, and left pi over 2, which must have an amplitude of 3 and a period of pi. That's what we're trying to sort of plug into this formula right here. So it's reflected vertically. That A is going to be negative, that amplitude. The amplitude is 3. So we took care of those two. So I'm just going to check some things off as we take care of them. Shifted up 3. That means there's going to be a plus 3 here. Left pi over 2. That means it's going to be x plus pi over 2 inside the parentheses. So we're leaving the bracket open for a b value. We know it's sine. So it's a period of pi. This is usually the tricky part. So what is the period formula? The period formula is 2 pi divided by b. The b value is the unknown right now. We know what the period's supposed to be. It's pi. So if you can solve this equation, you've solved for the b value that's supposed to go into our built function. So you can solve it by putting the pi over 1, cross multiply, do all that business. Or you could just ask yourself, what's 2 pi divided by blank gives me pi? 2 pi divided by 2 gives me pi. So b equals 2. For those of you who are like, I would really like to just solve the equation because my brain doesn't work in that way, you can put it over 1, cross multiply, b pi equals 2 pi, divide both sides by pi, b equals 2. And then here's just one final move that you could do. You could say this is 2x plus the 2's cross-cancel pi. I guess this is the more elegant way of talking about it. This is the more structurally informative way to write it. All right. I'm going to skip number 17. Cotangent. Let's do one with the cotangent. The cotangent works exactly like tangent in terms of the period's pi, except the asymptotes and the graph look a lot different. But the period for cotangent is always pi. So this cotangent function has a period of 4. That means pi divided by b must be equal to 4. So it might be a little tougher to just visualize what number you take pi divided by to get that 4. So this might be a place where you cross cancel, and then divide by 4 to get b by itself. It's pi over 4. The b value is pi over 4 for this cotangent function. Shifted left 1, and reflected vertically. Just put it out here. And then we need to call it cotangent, right? All right. Yeah, we got 3 minutes left. I could do this one, or I could do that one. I think this would be more informative. Let's do 13 and then call it a day for trig, at least with sketching graphs. So number 13, you got 2a minus 3b, blah, 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 blah. I'm going to put the negative 3b sine of c pi x minus d pi over 2 out front, and then put a plus 2a. This gives us a pretty solid idea of it's at least going to have this 3b right here is going to be our amplitude, and this 2a is going to be our vertical shift. So I know that the amplitude is going to equal the absolute value of 3b, and that the vertical shift is going to be up 2a. Now, I would normally have to do the division here, and this is no different. Sine of bracket c pi times x minus d pi over 2 divided by c pi. That's a tricky one. But if you just use your rules, flip the second and multiply, you can simplify this as much as you can. The pi's cancel. It's d over 2c. So negative divided by a positive is a minus d over 2c plus 2a. Yeah, so we got our amp is 3b. The horizontal shift is going to be right d over 2c. And did I catch? Yes to vertical reflections. Right? We didn't have a negative that could come out to change this. And then what am I missing here? The period. So the period is 2 pi, because that's normally what you would give to a sine. You divide it by c pi. So the period is 2 over c. All right, that concludes my lesson on the whole idea of sketching graphs and then just being able to analyze trig functions from a perspective that we are really concerned with how it moves and shifts and reflects and all that good stuff. All right, thanks for watching. See ya.